Okay, hi everyone. So I'm going to go through question 6. So for question 6, a car traveling along a flat road may be considered to have three forces acting on it. So the three forces is basically A, B, and C. So for part 1, we need to explain why it is necessary to regard force A and C as resultant force. So let's go through force A first. So force A is actually quite easy. It is the resultant force of the road on the car. So for the car to move forward, first and foremost, there must be some form of a forward friction. And then since the car is actually resting on the floor, so there must also be some form of normal reaction force. Okay, so essentially the resultant force A is actually a resultant of friction and normal reaction. So this is the reason why we need to regard force A as a resultant force, because it is mainly the vector sum of firstly the friction, the forward friction, and then secondly the normal reaction force wrought on the car. Now for part C, no, not part C, the resultant force C. Force C is actually earth on car. So immediately you should therefore realize that actually C is actually the weight. Okay, and for this particular part 1, most students would have understood weight as actually a single force, but to fully understand what weight itself is, okay, weight is actually a resultant force of all the weight of every part of the car. Okay, you must understand the way we have been solving weight, it is really just a mathematical convenience. So the way to really understand weight is, okay, it is not only acting at a single point, because the car, I can actually separate them into many different segments. Okay, each of these segments will have its own CG, and then each of these little segment will have its own little mass and therefore its own little weight. In fact, I can segment the whole car into its molecules and atoms, and each atom itself will have its own weight, okay, own mass. So how we understand weight normally in solving question, it is really just making a very convenient mathematical treatment, that is just to consider the whole weight to be acting at the CG of the car. But really essentially weight is actually made out of all the forces on every part of the car. So let me show you the type written solution. So we have type written solution here. So basically force A is the resultant of the vertical normal reaction force as well as the horizontal forward friction from the road on the wheels. Okay, force C is really the resultant force of the gravitational force by earth on every part of the car, but it is only considered to act at the center of gravity. Okay, it is really just a pure mathematical convenience. Here I have also written the examiner's comment. Okay, part A1 causes a surprising amount of difficulty. So examiner's report, okay, has already, Cambridge has also commented that this is surprisingly difficult for candidates. Okay, the key problem is too many candidates seems to think that all the weight of a car is actually acting through the center of gravity. Okay, this is not really true, because it is only considering weight of an object through the single point is really just for a mathematical convenience. Okay, the weight is really acting on every part of the car. So now let's move on to part 2. Force A has a magnitude of 8,200 Newton and is at the angle of 28 degree to the vertical. So force B is horizontal and has a magnitude of 1,500 Newton. So we are required to calculate the weight and mass of the car. So let me indicate some of the important key information that's been given. So we do know that force A is actually 8,200 Newton, and then force B is actually 1,500 Newton. We are required to find force C, given that the angle here is supposed to be 28 degree. So the car must be moving horizontally forward or backward. Okay, there should be no motion vertically, and therefore what that tells me is F net in the vertical direction should be 0. Therefore, the vertical component A sine 28 degree should be exactly equals to C, which is the weight. So I do know A is actually 8,200 sine 28 degree equals to C. Pressing the calculator, I should be able to get the weight of the car to be 7,240 Newton. And then we also need to find out the mass of the car. So mass of the car is basically just the 7,240 divided by the 9.81, giving me 740 kg. Okay, and then I need to find the resultant force on the car. So since we know F net Y is 0, so therefore the resultant force must be horizontal. So all we need to find out is just F net X equals to MA. This is Newton's second law. So taking rightward as positive. So basically A cosine 28 degree minus the 1500 Newton, the force B backward should be equals to MA. Okay, and then the resultant force is basically A cosine 28 degree minus 1500. So that's 8002 cosine 28 degree minus 1500. If you press a calculator, this should give me a value of 2350 Newton. Okay, that would be the resultant force on the car. And then to find the acceleration of the car, since this is equals to ma, so a is equals to 2350 divided by the mass of the car that we found earlier, giving me the final answer to be 3.18 meter per second square. Okay, and then finally, to answer part B, describe a situation in which motion is produced without friction being required. There are many such examples. So essentially, let's say dropping an object, there would be motion without friction required, because basically the motion is generated by the gravitational pull. So it is not the friction that provides for the motion. It is the gravitational pull that provides for the motion, and gravitational pull is definitely not friction because it is not a type of contact force. It is not a type of electromagnetic force. Okay, so another possible way to generate motion without friction is perhaps, for example, in our answer here, rockets. Okay, so how rocket actually move forward is basically it propels themselves forward by ejecting gas. So it burns fuel and then it ejects the gas backward. Okay, and therefore by Newton's third law and the conservation of momentum, the force backward on the gas will result in the gas pushing the rocket forward. Okay, so the backward thrust on the gas produce an equal but opposite thrust on the rocket. So this is another acceptable answer for part B. So this is the end of question 6. I'll move on to question 7 in the next video.